Now in this example, Shigley's 13-5, we want to go one step further. We still need the exact 30 times increase in speed, but we also want to make the shafts reverted or in line. What does that mean? It means I have input. In this case, again, this is weird because we're increasing the speed, not decreasing the speed. Nonetheless, we have input. So we have a big input so we can increase the speed, and then a little output. Then we have a shaft. Then we have our next big input. And for reverted, what that means is that this shaft, the input and the output shaft, are in line, like you have for transmissions and quite a few other applications. So these are in line. Input and output are in line. Well, what does that mean? That means that from here to here has to match from here to here. Those are called the center distances. So the center distances must match. What do I have to have for that? Well, that means that the radius of this one plus the radius of this one must equal the radius of this one plus the radius of this one. Now, diameter is just 2 times the radius. So to make sure that those center distances match, that means diameter 2, where's 2? I believe this is 2, plus diameter 3 must equal, maybe this is 4, gear 4, and this gear 5, diameter 4 plus diameter 5. Now we combine that with the rules we had up here to get the exact 30 to 1. Oh, I need to take this one step further. We have another fundamental equation here, which is the diametral pitch is the number of teeth divided by the diameter. So that means diameter times the diametral pitch equals n, the number of teeth. Now for all of them to mesh up, the diametral pitch has to be the same. So in this gear set, the diametral pitch is constant. So that means that N2 plus N3 must equal N4 plus N5. Now we got an equation we can work with. Because at the same time, we still have to satisfy the equation we had up here where N3 must equal, for this ratio to be 6, N3 must equal 6N2. Over here, N5 must be 5N4. Now, why can't I use the solutions from the previous equation? Why doesn't that completely revert? Well, if I look here from my previous solutions, if N2 equals 16, then N2 plus N3 equals 16 plus 96, which is 112. And N4 plus N5 equals 16 plus 80, which is 96. So with my previous solution using 16, this output shaft would be closer this way and it would not be reverted. So that does not work. 17 does not work either. You can prove that to yourself. Basically anything where I have both of the little gears having the same number, whether both of them are 16 or both of them are 17, it's not going to work. What I'm going to have to do is have the little gears have 2 different numbers. Those little gears have to have 2 different numbers of teeth. So maybe it's going to be 16 here and 18 here, or maybe it's going to be 17 and 18, or 17 and 19. I don't know. Is there a systematic way to do that? Sure there is. It's a tiny bit complicated, but that's what we're going to try. So let's go back to our governing equations. N2 plus N3 equals N4 plus N5. Secondly, N3 equals 6N2, and N5 equals 5N4. Now let's start substituting these in here. N2 plus 6N2 equals N4 plus 5N4. So that's 6N4 total. N2 plus 6N2 is 7N2. Now the smallest gears are N2, this one, N2, and N4. I got my numbers off here. So N2 and N4 are the smallest gears, so we want to see how they are going to be related to each other. So we solved our system of equations. We've got 7N2 equals 6N4. So N4 equals 7/6 of N2. Now what can we do with this? We need to find something that's divisible by 6 that also has a viable number of gear teeth. You can't have a gear with 6 gear teeth. That's too small. We said that. 12 gear teeth, that's also too small. I'm sorry, let me revert my own gear train here. So this is N2 and this is N3. That's why our equation said that N3 has to be 6 times. So the minimum number of teeth on N2 must be a multiple of 6. 6 is out because that's too few. 12 is out. That's also too few. What about 18? Let's try 18. Let's plug it into our equations here. So if N2 equals 18, then N3, this one, is going to be 6 times 18. And so that's 108. And we said N4 equals 7/6 of N2. This is why it has to be a multiple of 6, because now we have 18 divided by 6. That's 3 times 7 is 21. And N5 equals 5 times N4 from our equation up here. So 5 times 21 is 105. Now let's double check if we have satisfied our equation, which will make sure that we have a reverted gear train. N2 plus N3 equals N4 plus N5. So N2 is 18 plus 108 equals 21 plus 105. That's 126, and that's 126. So yes, it works. And let's check our product, our overall gear train ratio. We have 108 over 18 times 105 over 21, and that equals exactly 30. So we have a reverted gearbox, and it's doing exactly the speed increase that we want. Pretty cool, huh?